So, today, we're on lesson 9.4, solve polynomial equations in factored form. So far, what we've been doing is just adding polynomials and multiplying polynomials, and it's been halfway simple. We're going to start getting into things that are a little more complex, which is why we have to make sure you definitely know how to add, subtract, and multiply polynomials. So, we are going to start with today. Let me pull a couple things up. With something fairly easy for our warm-up. There's a reason we're doing this. You're going to be using this idea. So, find the GCF of 12 and 28. Obviously, GCF stands for greatest common factor. So, what is the greatest common factor between 12 and 28? 4. Good. So, we're probably to a point that we don't have to remember. The one way you could do it is list all the factors out, find the common factors, and then the biggest one, but we know the greatest common factor is 4. So how about between 18 and 42? 6? 6 is correct. Alright. Number 3 says the number in hundreds, and that's going to be important. The number in hundreds of sunscreen and sun tanning products sold at a pharmacy from 1999 through 2005 can be modeled by negative 0.8 t squared plus 0.3, this should be t, not x, plus 107, where t is the number of years since 1999. Okay, that's important. T, number of years since 1999. About how many products were sold in 2002? So when we solve this one, we first will set up our equation again. I would say negative 0.8 times t squared. Well, t is since 1999. So in 2002, that would be 3 years. So 3 squared plus 0.3 times 3, because t was 3, plus 107. If we go ahead and break this one down, 3 squared is 9. 9 times negative 0.8 is, what would that be? Negative 0.8 times 9. Negative what? 7.2 plus 0.3 times 3 would be our 0.9 plus 107. And if we went ahead and solved that one, remember, I'm just going to go 7.2 negative plus 0.9 plus 107. We should get 100.7. So about how many products were sold? Well, if it's in the number in hundreds, what would this number really be then? Well, it's 100.7 in hundreds. So if I want to find the exact number, I would have to times this by 100. Move the decimal place 2 spots. So it would be like 1, 2. So it would be 10,070 products approximately. And the reason we times by the 100 was because right up here, the number in hundreds was represented by the equation. So it was 100.7 hundreds. So we had to take that times 100. Okay, today's learning goal, we're going to use kind of part of our warm-up in today's work. I can use the zero product property to solve polynomial equations. Alright, we're referring to our quadratic equations booklet. So if you open up that very first one, it says quadratic equations, standard form, this is on the cover, ax squared plus bx plus c equals 0. And to be honest, this always made me feel so smart when I could do quadratic formulas. But we're going to work with this on how we're going to break it down, kind of doing the opposite of what we've been doing. If you open up the first cover, it tells you right here what a root is. I say root. So a root, which is also called a 0, is a solution to a quadratic equation. They're called zeros because if you were to graph the quadratic equation, the roots or zeros would be your x-intercept. Now, what we are making with this quadratic formula, we are making this little, I forgot what it's called. Sure, horseshoe. It's not. It's a parabola or something. So, I added in, and we make this. When we graph these aren't going to be linear equations. They're going to have their curve to them. Our root is going to be this and this. So what's that tell you our answer is going to be? What's something special about our answer then? It's not between those, it is those. Might be the same, no. It wouldn't have to, okay. But they don't have to be because this could be shifted. This could be like here. Well, then they wouldn't be just the opposite, like 2 and -2. But the biggest thing I want you to see is there's 2. So when we find our root or our 0, which is the solution, we're going to have 2 answers for it. Okay, there's going to be 2 of them. So the first thing is, this one's fairly simple. It's an easy idea that we have to get used to. It says, if we have 6 times x, 6x, equals 0, what does x have to equal? 0. Have to equal 0. Could be anything else. So we know x is 0. Okay, well what about this one? If I say x times 6, I switch the 2 numbers around. What would x have to equal this time? Still has to equal 0, right? Now, if your homework would be like this, we'd be set. So what we're going to learn about is the principle of 0 products. If you have 2 products multiplied together, such as m times n, and it equals 0. So if I have 2 products that are multiplying to each other, and it equals 0, then obviously either one or the other has to equal 0. Could they both equal 0? I mean, m could be 0, n would be 0, but we know that one of them has to be 0. The way we are going to use that is right here. Alright, so I have this. This is also in your foldable under the orange one, roots or 0. So if you want to put it in there, that way when we study for our ELC or EOQ, you have this to be your big reminder. But I have x minus 5, and it's being times by x plus 3. And it told me when I times those two, it's going to equal 0. So here's how we set this up. I'm going to take this first one, x minus 5. And I'm going to say x minus 5 and I'm going to set it equal to 0. Because it said that it's going to equal 0. Well, how do I solve for x? Katie?
0 plus 5.
Yeah. So I'm going to add this 5 here. So I first say x equals 5. Okay? We're going to take our second equation, x plus 3, the other number that was being multiplied, the x plus 3. I'm going to move it over here. we're setting that equal to 0. Which in that case, x would have equaled -3. We subtract our 3 from both sides. X equals -3. And then that is what we would say our answer is. X equals 5 and -3. So if we would draw that quadratic formula again, our x-intercepts are located at +5 and at -3.
Just wondering, is using a comma the only way to write that, or if someone writes like 5 or -3, would that still work?
I don't know if you want to use or. I mean, you can put a semicolon between, or you can say and. I don't know if you want to say or, because it is both of them. So we're going to try another one together. On this one, it's x times x minus 22. So I have to first, we're going back to, all this is going back to this principle of 0. Two products being multiplied by each other. So if I look for my two products, there's one of them, x, it's all by itself, and the other one is x minus 22. So I'm saying when I times these two, it's going to equal 0. So one of those two products has to equal 0. That's what we're solving for. So I'm going to take this first one and say x equals 0. That one's simple. We're done. X is 0. We need those in our homework. The other one, I'm going to say x minus 22 equals 0. Which, to solve Heckman, what would I do? Add 22 to both sides. And we'd get x equals 22. So, once again, we get x equals 0 or 22. Should say and. I'm saying 40. Okay. Questions on this part so far? Okay, there's a third one, and I want you to try this one by yourself. I'm going to pause my video for a second. What are my two products, though, that we're finding? What's one of them that I'm going to highlight first that will be set to 0? 2y plus 5, good. And what's the other one? Alright, so go ahead, set both those equal to 0, and let's see what you find for x. Just make sure we're all on the same page. I don't know if they're talking about this. So this would be positive. So you put the positive first. I think. I mean, I'll check that. I didn't see that before. I want to make sure that they're not talking about this. So we'll check on this. All right, let's look. 2y plus 5 equals 0. Going through this, you should have minus 5. We'd have 2y equals -5. Divide by 2. And we would have had y equals -5 halves. Okay? And then when I go over here, add 5 to both sides. So I'd have 7y equals 5, divide by 7. And we'd have y equals 5/7. So when I look for my answer, it's going to be these two. Even though they're using the variable y, we're still talking about our root, so it's going to be our x-intercepts. But I would say 5/7 comma -5 halves. You could usually get, it's easier to use a fraction because a lot of times if it's a decimal, it's a repeating decimal or a non-ending decimal, non-terminating one. But like negative 5/2, if you said negative 2.5, that's okay. It's not a big deal. It's more typical to come across fractions than decimals. Yes.
Does it matter which one you put first?
I don't think so. You guys' foldable said something about the first term can't be negative.
Yeah.
Mine didn't say that, so I want to make sure. I don't want to tell you wrong. I don't know if that's talking this or the other when we factor, because I'll show you something when we pull out here in a little bit. But it really shouldn't make a difference which one you put in. All right. This is where some people excel, that this really hits their wheelhouse. They like this, their brain functions. Other people, it takes a couple seconds to get this. Factor out the greatest common monomial factor. Now, we are going to look at our equation for this monomial, and we're going to, or this binomial, but we're going to factor out one binomial. We're going to take one thing out. We're going to do the opposite. Up to this point, we've done things where we distributed in. Now, we are going to go the opposite way. So to do that, I'm going to look at this equation. 4y to the 4th minus 16y to the 3rd. Biggest thing I want to look for is, I want to pull out the common factors. I want to pull out the greatest common. The easiest way to do so is, first pay attention to your coefficient. So, what is the greatest common factor between 4 and 16? 4. So I'm going to take out 4. Okay, now let's look at our variable. Y to the 4th and y to the 3rd. Well, obviously they both have the variable y, but what's the largest degree of the smallest one? 3. So if you look at this, let's say that again. I have y to the 4th and y to the 3rd. I'm going to look at my smallest one, and I'm going to take all of it away. Because that's the greatest common factor. The common factor is y in what degree? To the 3rd. I can take a 3rd, or not a 3rd, but a 3rd power away from each one of those. Now when I do this, it's like I'm doing the opposite of distributing, I'm dividing. So when I get my answer, if I did this, I'm going to have 4y to the 3rd. That is what we took out. And in parentheses, this is going to be what I'm left with. So, we had 4y to the 4th. So 4 divided by 4 is 1. So I don't really have anything left there. Y to the 4th divided by y to the 3rd would leave me with just y to the 1st. Yeah. So we'd have y left. This right here is 4y to the 3rd times y. That's what we took out. If we look at the next one, my negative 16. Well, negative 16 divided by 4 is, so we still have negative 4. I had y to the 3rd, and I took y to the 3rd out. So I'd have nothing left. It'd just be this. That is my answer. When we're factoring out, we took the greatest common factor, which was 4y to the 3rd, and we took it out of each one of those equations. And we broke it down. If you need to check yourself, which I like to do a lot of times, is do the opposite now. Distribute it back in. 4y to the 3rd times y is 4y to the 4th. Negative 4 times 4, or 4 times negative 4 is negative 16. Y times nothing is y to the 3rd. I should end up with my same equation. So we're working on factoring, going the opposite way. If we try it on this one, we're going to do the same thing. first, I'm going to look at my coefficients. So, my greatest common factor between 15 and 6 is 3. Okay? My greatest common factor between p to the 7th and p squared. P squared. Good, Daddy. We know it's the variable p, but we can only go to the second power because that's the smallest one we have. I can't say third because I can't take the power to the 3 out of power of 2. So you can look at your smaller one. So p to the second power. So now we're thinking, okay, I'm dividing by this. If you think of that like I am dividing, I'm going to come back down and say, I have 3p squared. That was my greatest common factor. 15 divided by 3 is p to the 7th divided by p squared. P to the 5th. Positive 6 divided by 3. P squared divided by p squared.
1.
We don't have to say anything because when we distribute, that would get left. This is my answer. How do we feel on this part so far? Any big questions? Like what I did below? Now I just did this below just to show that it came out the same. So you do not have to do this thing. So this is our final answer. And you're going to see why. Now, if you start thinking about what we just did, there's probably a reason to this now. What did we just work on up here? We had two products. We set them equal to 0 to find out what x would be. Now, when I take this, I'm going to do the same thing. Because right now this was adding, but now I have them as multiplying. That's why we're going to be doing this factor. So then I could set them equal to 0. So, solve the equations. Well, I need to find out what my x is going to be, or on this one, what n is going to be. Well, I can't do what we just did before, setting them to 0, because they're being added. Remember, up here, if I can scroll to it, the principal is 0. You have to have two products multiplying by each other to equal 0. Well, right now, the two are adding. So what I'm going to do is factor this first. So our first step is to factor this. Step 1, I'm going to find my greatest common factor. So I start by looking at my coefficient. Negative 10 and 35. My greatest common factor is
5.
Yeah, and we want to pull that negative out. Okay? I got to double check. From what I was told we have to. I always did it just a positive, and it came out the same answer. But we'll pull out the negative 5. Okay? And then between our variable, n squared and n, we'd be able to take out n. Good. So what will we be left with? So our first step was to find the greatest common factor. So we go ahead and do that. Negative 10 divided by 5 is going to leave me with 2. N squared divided by the n, I'll be left with just n. 35 divided by negative 5 is good, negative 7. And the n divided by n is okay. We have now factored that. And you'll see the main reason we've done that is now instead of having an addition, we now have a product. Negative 5n times negative 2n minus 7. We are now to our second step. We can find the zeros, or the roots, whatever we want to call them. We will do so by taking negative 5n, and it equals 0. Both negative 5n equals 0, n would have to equal, if I divide by negative 5, if I have 0 over negative 5, that just equals 0. We're going to take our 2n minus 7, and I'm going to add 7 to both. 2n equals 7, and you divide by 2. N equals 7 halves. So that will be what our answer is. Our answer is either going to be n equals 0 or 7 halves.
So when you did negative 5n equals 0, why didn't you do like plus 5 to get negative 5?
Because it's not negative 5 plus n. It's negative 5 times n. So we undo that by dividing by negative 5.
Okay, and you get 0?
Yeah, so you have 0 divided by negative 5. 0 divided by anything is 0. Alright, let's have you, before we start this one, what's the problem with this one? Doesn't equal 0. Can we change it so it does?
Yeah.
How?
You subtract 6k, and then you get 3k, the second power, minus 6k equals 0.
So, we have to make sure we're set to 0. Okay? So we have this. Now we're going to go ahead and find number 1. We're going to make our greatest common factor. So, I'm going to stop. I'm going to have you guys do step 1 all by yourself. Find the greatest common factor and factor this down just like we did right here. I'm going to pause and I'll have you look. So, my greatest common factor between this, I'm going to kind of go quick since this is the last one we'll do in class, should have been 3k. 3 is my greatest common factor between 3 and 6, and k is the greatest. The k is the greatest between k squared and k. So when I go out, this would have been just k minus 2. Make sure I'm doing all this right. We still have all this equal to 0. So then step 2 is we solve for 0. I would have said 3k equals 0. You divide by 3, so k equals 0. K minus 2 equals 0. We add 2, k equals 2. So k would equal 0 and 2. Okay. Like I said, I'm going to pause so I can hand back those quizzes. We still have about 4 minutes. But I want to make sure we hand back. But before you stop, biggest thing here, nothing's changed. It's just 2 variables. Nothing is changing. Look at your greatest common factor between your coefficients, your greatest common factor for the A, the greatest common factor for B. This is the one I want to make sure you understand. To set this one up, I would write this equation again when it says the function of x equals, well, I'm going to be able to rewrite this just as the negative 2x squared plus x equals 0. Then you can do everything the same. First, find our greatest common factor, and then 2 are zeros. We do have a story problem. This one's a little tricky, so I will, like I said, during third period, I will record this and repost it. Okay? Any quick questions before we stop? Alright, make sure you bring your foldable each